on the Great Plains chasing storms, trying to get our instruments into a storm. We just got some into that storm right there behind us.
Yeah, what Dr. Richardson and I are trying to do is, it's a little like the movie Twister, I guess. We're trying to float airborne probes through a storm. I guess what's different than Twister is we're not trying to get things into the tornado. That actually wouldn't tell us a whole lot other than that it's windy and the pressure is low, which we already know. We're actually just trying to map the three-dimensional variations in temperature. That's really important to us to try to understand how tornadoes actually form. So here we have one of our probes. This is what it looks like. This is what's flying in the air right now. It looks not much more fancy than a cup of coffee, but actually it is just a styrofoam cup. But on the inside are electronics. There's a battery, some circuitry, GPS receiver, and then this thing that hangs out the side has a temperature probe and a relative humidity probe. This thing here is an antenna. It's very important because it's what communicates to our computers once the probes are airborne. And right now we're tracking 6 of these in flight.
So we attach them to 2 balloons and then we release them into the storm. And now we can see the data that's coming in.
So here we're tracking them in Google Earth. We can see some have gone up somewhat high because they got caught in the uplift of the thunderstorm, and others have kind of stayed in the rain and sampled the cool air, which is really important for how tornadoes form.
We're doing that because we have a lot of theories, and a lot of them depend on knowing what's going on underneath the storm. And we have measurements at the ground from cars that have instruments on them, but we don't have measurements that are in the air above that. And that's really critical to our theories. So we're trying to sample that and get more data to confirm some of what we're thinking happens.